We're happy to welcome Professor Hubert Girault from the EPFL in Lausanne, Switzerland. Hello, Mr. Girault.
Hello.
We're going to discuss carbon capture with you. Maybe to start, some figures about the quantity of carbon captured nowadays. What can we say?
Carbon capture nowadays, according to the International Energy Agency, is about 230 megaton per year, which is mainly to do urea for fertilizer and to do enhanced soil recovery. But compared to the 37 gigaton produced every year, this is really in the noise.
We have so much progress to achieve, of course. On the technical side, what are the three main techniques used today?
The oldest is based on amines. So amine is a molecule with a nitrogen at the end. And basically, those molecules can capture the CO2 to do other molecule called carbamate or bicarbonate. And those solvents have been used for many years now at the industrial scale. And companies like Mitsubishi Heavy Industry, like Linde, and so on, all offer plants for CO2 capture to be used straight away for urea production, for example.
So this is the first one.
That's the first one. The second one is what you would call the membrane technology, where you pass gas mixtures through membranes, and basically, according to the size or other properties like polarity, you can separate molecules. That's the second big one. And the third big one is what I would call absorption techniques, where you will absorb CO2 on a material. It can be inorganic, it can be organic, polymer, and so on. And then once your system is full, it's a bit like activated carbon in your kitchen, if you want. Once the system is full, you have either to warm up the filter, which has captured the CO2 to release it, or you can change the pressure. And there is a very interesting process called electroswing, where you would absorb the CO2 on a redox polymer, a quinone, where basically when you change the polarity of your membrane, you either absorb or desorb. And this one is a process developed by Verdox from MIT in the US, which I find very elegant as an electrochemist, of course.
Do we have some other technologies on the way? Because we know there is a lot of innovation in the hydrogen industry. So what about some other solutions for CO2 capture?
Well, basically, yes and no. You will improve the membrane, of course, because membrane have a final lifetime, so membrane gets blocked. You can, of course, develop other swing technique. You can develop, of course, better membrane to have a better CO2 absorption. But if you look, for example, what Climeworks is doing in Switzerland, but also in Iceland and now in Texas, the technology is quite mature. Regarding the major one, the amines, there has been decades of development there, and the progress will be incremental.
Okay, so you mentioned several countries and companies. So who is the most in advance today on the planet?
Difficult to say, but let's say all the big industrialized nations have a program on CO2 capture by amines. Of course, companies like BASF are very active, Linde in Germany are very active, Air Liquide in France is very active, Babcock in the US. The US has many companies involved in carbon capture. And of course, all the major oil companies now either are active or are looking at carbon capture. And once the big money will come in the game, new technology will evolve.
Thank you, Professor Girault, for being with us and for all these explanations.
Maybe a word about the cost, if you want.
The cost, of course, it matters.
So basically, when you speak just about carbon capture, one speak, roughly speaking, about $100 per ton. So if you take, for example, the production of hydrogen by SMR, so the reaction is CH4, so methane molecule, plus 2 water molecule, that gives 4 hydrogen molecule plus 1 CO2. So for each ton of hydrogen produced by SMR, you consume just from the reaction 5.5 tons of CO2. With the heating aspect and so on, people usually count 10 tons of CO2 per ton of hydrogen. So if the cost of just the capture is 100 francs per ton, basically you add, or €1 or whatever, you add about €1 per kilo of hydrogen just for the CO2 capture, not transport, not storage.